This is question number 8 from S.C. Verma book. We are given a car graph. The time is on x-axis and velocity is in the y-axis. And the velocity, it's increasing with time. And we are required to find out the distance traveled by this car in period from 0 to 8 seconds. So this is actually a high school problem. It's not a class 11 problem. All you have to see, look at it carefully. The initial velocity is given and it's uniformly increasing velocity, and final velocity is 20. The time is given, everything is given. All you need to do is convert this into these numbers and apply some of the formula. And usually such problems, to try it with the formula, but try to think about how you can calculate it using this graph. And I will give you a hint that look at the area of the graph in this curve and the time axis. So keep trying this problem till I prepare some description or explanation of this problem. So what I have done is I have plotted a graph of variation of this velocity v with time t, and we are required to find out the distance travel. This is basically the speed of this car. The distance travel from time t1 to time t2, and it's not a very nice looking straight line. It's any random arbitrary curve. It can be something like this. So how do we solve this problem? We don't know anything about acceleration and anything. So what we do is, in this curve, I'm going to divide it into many small strips like this. Hundreds of thousands of strips. All, let us call it between TA and TB. That makes my life easy to do calculation. This time delta, and let's say each of them has a time interval of delta t. Delta t, this is delta t, this is delta t, hundreds of delta t time. And what we are trying to do is, let us say since these 2 points are very close, so this time, let's say the average velocity in this period is v1. Then the distance travel from this time, in this time interval, will be this velocity v1. This velocity v1 is about the same. If you take the average between these 2 points, the average velocity will be same because this time interval this time is same. So the average velocity, the distance traveled in this time interval will be velocity v1 multiplied by this time. And we can write v1 into t, into delta t. And then we move on to the next interval. This next interval is, let us say this average velocity in this particular duration is v2. So the distance travel from here to here will be v2 multiplied by delta t. For this problem, it's not necessary to keep the delta t same, but we are keeping it very small, so let's keep this same. And so on for the third strip. The distance travel is again velocity multiplied by the time, v3 into delta t, and so on and so forth. And the last, let's say it's vn multiplied by delta t. Vn will be the last strip. Now what is v1 into delta t? We can think this one, if this is very small, we can think this one as a rectangle in shape, and this v1 into delta t is nothing but the area of this rectangle. In the same way, this thing is the area of this rectangle, and third one, this area of this rectangle. And if we add up all of them, then this gives the area under curve and time axis. With this method, you can find the distance traveled by just looking at the area under the V graph and the time. And now let's come back to this problem. We are required to find the distance in this time interval. And what is the area of this triangle? It is half into base is 8 and the height of this triangle is 20. This will be equal to 4 and this 80 meters. What is the advantage of this method? If we were, for example, required to find if a car moves something like this, like in a circular fashion, maybe it's like a fourth of a part of a circle like this. You are given the speed varying like this, and this is in the form of a shape of a circle. Even then you will be able to find out the distance traveled by the car. So for the next part, the acceleration is uniformly varying. So you can you can use the same formula, delta V by delta T. Delta V is from 0 to 20, so it's 20 minus 0 divided by time, which is 8. 8 into 2, 16, 402.5 meter per second square. This should solve your problem. And if there are any more questions or doubt, you can put it in the comment section.